Hi. In this lecture, we'll explore how to set up an early stopping mechanism with TensorFlow. The fit method contains an argument called callbacks. Callbacks are functions called at certain points during model training. Fortunately, there are many different readily available callbacks. You can draw your training process in TensorBoard, you can stream the results into a CSV file or a server, save the model after each epoch, adjust the learning rate in weird ways, and these are just some of the options. You can also define any custom callback you may want to use. However, the one we'll focus on is early stopping. And no wonder. Early stopping is the definition of a utility called at a certain point during training. Each time the validation loss is calculated, it is compared to the validation loss one epoch ago. If it starts increasing, the model is overfitting and we should stop training. Okay. Since the early stopping mechanism is a hyperparameter in a way, let's declare a new variable called early stopping, which will be an instance of TF, Keras, callbacks, early stopping. As you can guess, there is a readily available structure we can use. So, all we need to take care of are the particulars of this early stopping mechanism. By default, this object will monitor the validation loss and stop the training process the first time the validation loss starts increasing. All right. Now that we've got our early stopping mechanism, it's time to implement it in our training process. As we suggested, we should add a callbacks argument to the fit method equal to a list of callbacks. In our case, this list will have a single element, our early stopping variable. Let's retrain the model. We can see that the new training lasts for less than 20 epochs, and the final accuracy of the model is around 90%. Obviously, the first time we trained our model, we had overfit. The result was around 2% higher, and we can attribute this solely to overtraining it. Now, if we examine the validation loss, we'll notice that the first time it increased was during the last epoch. Moreover, it increased only slightly. Sometimes, if we notice that the validation loss has increased by an insignificant amount, we may prefer to let one or two validation increases slide. To allow for this tolerance, we can adjust the early stopping object. There's an argument called patience, which by default is set to 0. There, we can specify the number of epochs with no improvement, after which the training will be stopped. It's a bit too strict to have no tolerance for a random increase in the validation loss. Therefore, let's set the patience to 2. This way, we'll be completely sure when the model has started to overfit. All right. With this adjustment already implemented, we can rerun the code. Depending on your problem and dataset, the difference may not be crucial. However, this is yet another debugging tool of sorts that you have at your disposal. This time, the accuracy is between 90 and 91%. Definitely worse than our overfitted model, but slightly better than the one with no patience. What about its interpretation? Well, with your extensive knowledge, you can easily interpret the result, so there's no need to spend too much time on that. Now, there are several important outcomes I'd like to point out, and they are all conceptual rather than quantitative. First, the final validation accuracy of the model is around 90%. The priors were 50%, which means our machine learning algorithm definitely learned a lot. It managed to classify around 90% of the customers correctly. Sounds great, right? In other words, if we're given 10 customers and their audiobook activity, we'll be able to correctly identify future customer behavior of 9 of them. But how does this help us in practice? We can use this information for what we intended to. We can focus our marketing efforts only on those customers who are likely to convert again. Take a second to reflect on this amazing discovery. In the beginning, we started with a bunch of raw data, which did not make a whole lot of sense to anyone who was not in this line of business. Moreover, many variables were binary, and there were lots of missing values. Even the orders of magnitude had nothing in common. If we were to manually explore the data and give an educated guess on whether a customer would convert again, it is likely that the result would be as good as blind guessing. My personal bet is that a human would do even worse than the latter. With some descriptive statistics and regression models, we'd get a better result, but I assure you, it wouldn't be very impressive. And you would definitely need a lot more than 30 minutes we spent in order to create this model. It is extremely hard to predict human behavior, and most of the time, it's even counterintuitive. However, the machine learning algorithm we created here is a new tool in your arsenal that has given you an incredible edge. Moreover, using the algorithm is a skill you can easily apply in any business out there. So, basically, what you did is leverage the power of artificial intelligence to reach a business insight. Congratulations and great work!